Hello everyone, welcome back to another video on my YouTube channel. Today we'll be looking at a problem called best time to buy and sell stock. This is another problem in the blind 75 list of problems. Let's go through the question once. We are given an array prices and prices I is the price of a given stock on the ith day. And we want to maximize our profit by choosing a single day to buy stock and choosing a different day in the future to sell stock. So what that means is, for example, I buy the stock today. I can only sell it after today, not on the same day, not on any previous day. And the difference in the prices for which I sell minus buy price, that I want to maximize. Let's see it with the first example. So first example is 715364. Now in this example, I've drawn this chart to depict it. So this is the first day, second day, third day, fourth day, fifth day, and sixth day prices. Now to maximize the profit, I would buy it on day 2. That is, buy it for price 1 and sell it on day 5. So 6 minus 1, 5 will be my profit. So in formal terms, if I write it, in terms of the array, if I have to write it, what we need to do? We need to find max of price j minus price I, where j and I are indexes in the array. And for every I and j, for all ij such that j greater than I. So the selling date should come after the buy date. So we need to find this. Now the most straightforward way to find this would be to apply a brute force approach and find all the pairs. So for example, if I buy on 7, sell on 7, see what profit I'm getting, sell on 5, sell 3, sell 6, sell 4, and then start with buying on 1, sell on 5, sell on 3, sell on 6, sell on 4, and similarly calculate all the pairs. But the time complexity in that case would be O of n square, as we are forming n into n minus 1 by 2 pairs, which will be nc2. And the space complexity in this case would be O of 1. But we are given that the length of the prices I array is 10 to the power 4. So can we reduce this time complexity and find a better solution? Yes, we can. Let's look at that solution now. Now, if you look at the chart which I just formed from this input array, I can see that the answer we need to get is difference between this and this. So this will be our answer. And the points of importance in this graph are the peaks and the valleys. So these are the peaks on which I can sell, and the valleys on which I can buy are these. Now, if you observe this graph carefully, you will notice that we need to find for every peak the minimum value behind it. So for example, for this peak also, there the minimum value behind it was this one. For this peak also, it was this one. And similarly, if it was anyway in front of it, then we'll go to the minimum value. Or even if some value comes down below like this, and I reach here, in that case, the minimum will be here. So minimum will keep on changing as we progress. So what we can do for that is maintain two variables, mean price and max profit. And as we iterate through the array, by going left to right. We keep track of this min price, whatever was the minimum price previously, and also keep calculating max profit as we reach each number in the array. And at the end of it, just return the max profit as the answer. Now, what would be the time complexity of this approach? As we are doing only one pass and maintaining two variables, it would be O of n. And space complexity would be O of 1. Let me show this in the input array real quick. So now let's say we are given the example in an array, and the initial values of min price and max profit I took as int max, which is a very large number, and max profit is 0 initially because we can't make negative profit. So say in array all of the numbers are decreasing, for example 4, 3, 2, 1, then I won't buy and sell on any days and max profit would come out to be 0. Now let's start with this array and let's move from left to right. Okay, we come to 7. 7 max profit will remain 0 because I can't sell on first day. Min price will become 7 because 7 is less than int max. Then moving on to 1. If I sell on 1 and buy on 7, then it will be minus 6 profit, which is less than 0. So max profit will remain 0. Min will become now 1. And similarly, when we move on to 5, the min is now 1. So 5 minus 1 is 4. 4 will be the max profit now. And min will remain 1 because 5 is greater than 1. Now moving on to 3. 3 minus 1 is 2. So I don't want to have a profit of 2. So max profit will remain 4. And min price will remain 1 because 3 is greater than 1. Now moving on to 6. If I sell on 6, what will be my buy price? It will be the min price. So 6 minus 1 is 5. So 5 profit is greater than 4. So now max profit will become 5. And min price will still remain 1 because 6 is also greater than 1. Now moving on to 4. If I sell on 4, 4 minus 1 is 3 and 3 is less than 5. So max profit will still remain 5 and min price will still remain 5. So at the end the value of max profit is 5, which will be my answer. Now let's see how we'll implement this in code. Now we are given a function called max profit and an integer vector of type int called prices. Now what did we discuss? We'll take two variables called min price and max profit. And min price I'll assign it to a very large value, which is int max. And max profit initially I'll take 0. Now I'll iterate this prices vector. So for auto price and prices, what do I want to do? If price is I, which is the current price, minus the minimum price is greater than the max profit, I would change this to price minus min price. A better way to write this would be to just use max function. So I'll just update that. Max profit is max of max profit comma price minus min price. I can remove this then. And after that, what I will do, I also have to update the min price. So if min price is minimum of min price and the current value. At the end of this, just return the max profit, which I'll get. Now let's try running it. So both the input test cases worked. Now let's try to submit it. As you can see, our OFN solution also worked. Hope you got the solution. Thank you for watching. Do like, share and subscribe for more such future videos. Until then, happy coding.